Welcome, dears. In this part 4 of Matrices and Determinants series, we will discuss three fascinating concepts. These are addition of matrices, subtraction of matrices, and multiplication of matrices by Scalar. For ease of understanding these concepts, let's start with this tabular data. Abem, Mariamawit, Ibrahim, and Samrawit are grade 11 students competing to stand first in the class. The English, mathematics, physics, and chemistry marks of these 4 students in 2 tests, each of which are marked out of 20, are given in the tables below. These 2 tables summarize the test result of each student on each subject. The question is, what's the total mark of each student on each subject? To find each student total mark on each subject, what we are going to do is just to add the individual test results on each subject. That is to mean that Abem's English test result in test 1 plus his English result in test 2. In test 1, Abem scores 20, and in test 2, his English score is 18. So 20 plus 18 is equal to 38. In this case, what we do is just we add the value of row 1, column 1 position at the left with the value of row 1, column 1 position at the right. Row 1, column 2 positions in these 2 tables represent the mathematics score of Abel in test 1 and test 2 respectively. So his total mark out of 40 is 20 plus 20 equal to 40. Here also, we add second column of first row at the left with second column of first row at the right. Considering these cases, we can generalize the addition of this tabular data as element at column N and row M of the left-hand side table has to be added to the corresponding element as the right-hand side table, meaning 18 plus 19 equal to 37 and 19 plus 19 equal to 38 for the remaining data of row 1. When we come to row 2, that's Mariamawit's score, 19 plus 18 equal to 37, 19 plus 20 equal to 39, 20 plus 17 equal to 37, and 20 plus 20 equal to 40. Ibrahim's score, 18 plus 19 equal to 37, 20 plus 18 equal to 38, 20 plus 20 equal to 40, 18 plus 19 equal to 37. Samrawit's score, 18 plus 20 equal to 38, 19 plus 19 equal to 38, 20 plus 18 equal to 38, and 20 plus 18 equal to 38 again. As we discussed in part 1 of this series, tabular data can easily be transcribed into matrix form just by removing the row and column headings and the vertical and horizontal lines that separate the table elements, and enclosing the elements in square or round bracket. Let's start the transcription by forming a square bracket and copying the elements of the table to the corresponding matrix. The addition rule we applied for tabular data has to be applied to matrix data because both of them are stating the same thing, meaning row 1 stands for the mark of Abem in 4 subjects, that's English, mathematics, physics, and chemistry respectively. Row 2 stands for Mariamawit, row 3 stands for Ibrahim, and row 4 stands for Samrawit. Thus, in row 1, 20 plus 18 equal to 38, 20 plus 20 equal to 40, 18 plus 19 equal to 37, and 19 plus 19 equal to 38. Row 2 addition, 19 plus 18 equal to 37, 19 plus 20 equal to 39, 20 plus 17 equal to 37, and 20 plus 20 equal to 40. Row 3 addition, 18 plus 19 equal to 37, 20 plus 18 equal to 38, 20 plus 20 equal to 40, and 18 plus 19 equal to 37. Row 4 addition, 18 plus 20 equal to 38, 19 plus 19 equal to 38, 20 plus 18 equal to 38, and 20 plus 18 again equal to 38. The subtraction of matrices also follows the same principle. That's in subtracting 2 matrices, each and every element in the second matrix has to be subtracted from the corresponding element in the first matrix. Having these concepts in mind, let's define addition and subtraction of matrices. Let A equal to A sub ij with an order m by n, and B equal to B sub ij with an order m by n are 2 matrices. Then the sum of A and B is obtained by adding the corresponding elements, that's A plus B equal to A sub ij plus B sub ij with order m by n, and the difference of A and B is obtained by subtracting the corresponding elements, that's A minus B equal to A sub ij minus B sub ij with order m by n. This definition addresses 2 basic things. The first thing is Addition and subtraction of two matrices are possible only when they have the same order. Here, the order of A is m by n, and also the order of B is m by n, meaning they are equal. Second, in adding or subtracting matrices, a given element has to be added to or deducted from the corresponding element in the other matrix. In other words, elements with similar subscript can be added or subtracted each other. In this definition, element A with subscript ij is added to another element B with subscript ij, and element B with subscript ij is subtracted from another element, that is A with subscript ij. If we are asked to add this 3 by 3 matrix expressed by denotation of A sub ij with this 3 by 3 matrix expressed by denotation of B sub ij, the addition goes as follows. The orders of the two matrices are equal, that's 3 by 3. So we can add elements of the two matrices having similar subscripts. That's A sub 1 1 plus B sub 1 1, A sub 1 2 plus B sub 1 2, A sub 1 3 plus B sub 1 3 for row 1 elements, A sub 2 1 plus B sub 2 1, A sub 2 2 plus B sub 2 2, and A sub 2 3 plus B sub 2 3 for row 2 elements, A sub 3 1 plus B sub 3 1, A sub 3 2 plus B sub 3 2, and A sub 3 3 plus B sub 3 3 for row 3 elements. Subtraction of these two matrices also follows the same procedure except substituting addition by subtraction. To illustrate on multiplication of matrices by scalar, let's return to the former tabular data and let's make this addition. Because of time constraint, the school can't schedule the third test. Rather, teachers are instructed to convert test 1 to out of 40. What is the converted mark of each student? 40 means 2 times 20. So in converting test 1 result to out of 40, what we are going to do is simply multiply each and every result in table 1 by 2. As we discussed above, this tabular data can easily be transcribed into matrix form just by removing row and column headings and the straight lines that separate the rows and columns. If we assign this matrix equal to A, then to A equal to 2 times matrix A. Just like tabular data above, these two outside the square bracket has to multiply each element of matrix A. Therefore, multiplication of matrices by scalar can be defined as follows. If R is any real number, that's scalar, and A equal to A sub ij with order m by n is a matrix, then Ra is a matrix obtained from A by multiplying each element of A by R, that is Ra equal to R times A sub ij with order m by n. Let me elaborate this definition by using a matrix. If A equal to 3 by 3 matrix having elements expressed in the form A sub ij, then Ra equal to R times matrix A. This R outside the bracket multiplies each and every element of matrix A. Next, let's see application of the above definition for solving problems. Here are the problems. If A equal to this 3 by 4 matrix and B equal to this matrix of same order, then calculate A plus 3B and 2A minus 2B. Before going to addition and subtraction of these two matrices, we have to reply this question. That's, can we add and subtract these two matrices? The answer is yes, because both of them are 3 by 4 matrices. So the addition is possible because the matrices have the same order, and subtraction is possible because the matrices are the same order. Let's start with A plus 3B, which is equal to A means matrix A as it is, and 3 times B means multiply each element of matrix B by C. That's 3 times 9, 3 times 12, 3 times 6, 3 times 5 for row 1 elements, 3 times 13, 3 times 8, 3 times 11, and 3 times 14 for row 2 elements, 3 times 15, 3 times 10, 3 times 16, and 3 times 20 for row 4 elements, which is equal to matrix A plus the second matrix, that's 3 times 9 is 27, 3 times 12 is 36, 3 times 6 is 18, 3 times 5 is 15, 3 times 13 is 39, 3 times 8 is 24, 3 times 11 is 33, 3 times 14 is 42, 3 times 15 is 45, 3 times 10 is 30, 3 times 16 is 48, and 3 times 20 is 60. What we left is adding elements of matrix A with the corresponding elements of matrix B. That's 25 plus 27, 35 plus 36, 20 plus 18, and 15 plus 15. What we did here is just we add elements located in the same row and column. When we come to row 2, 10 plus 39, 21 plus 24, 24 plus 33, and 12 plus 42. Addition of row 3 elements, 30 plus 45, 40 plus 30, 7 plus 48, and 22 plus 60. Let's solve each addition. 25 plus 27 equal to 52. 35 plus 36 is 71. 20 plus 18 is 38. 15 plus 15 is 30. 10 plus 39 is 49. 21 plus 24 is 45. 24 plus 33 is 57. 12 plus 42 is 54. 30 plus 45 is 75. 40 plus 30 is 70. 7 plus 48 is 55. And 22 plus 60 is 82. When we come to the second equation, that is 2a minus 2b, it's about scalar multiplication and subtraction. Let's use a step-by-step approach for solving this problem. 2a minus 2b equal to 2 times a minus 2 times b. Matrix A and matrix B are already given above in the question. These two outside the bracket multiplies each and every element inside the square bracket minus also these two multiplies each element of matrix B, which is equal to 2 times 25 is 50, 2 times 35 is 70, 2 times 20 is 40, and 2 times 15 is 30. When we move to row 2, 2 times 10 is 20, 2 times 21 is 42, 2 times 24 is 48, 2 times 12 is 24. In row 3, 2 times 30 is 60, 2 times 40 is 80, 2 times 7 is 14, 2 times 22 is 44. When we move to the right hand side matrix, 2 times 9 is 18, 2 times 12 is 24, 2 times 6 is 12, and 2 times 5 is 10. Row 2 of the right hand side matrix, 2 times 13 is 26, 2 times 8 is 16, 2 times 11 is 22, and 2 times 14 is 28. In row 3, 2 times 15 is 30, 2 times 10 is 20, 2 times 16 is 32, and 2 times 20 is 40. From the definition of matrix subtraction, we have learned that elements which are located in similar row and column have to be subtracted each other. That's 50 minus 18, 70 minus 24, 40 minus 12, 30 minus 10. When we come to row 2 elements, 20 minus 26, 42 minus 16, 48 minus 22, and 24 minus 28. The reduction in row 3 is 60 minus 30, 80 minus 20, 14 minus 32, and 44 minus 40. Now, what we left is just to solve the subtractions. 50 minus 18 is 32, 70 minus 24 is 46, 40 minus 12 is 28, 30 minus 10 is 20, 20 minus 26 is negative 6, 42 minus 16 is 26, 48 minus 22 is 26, 24 minus 28 equal to negative 4, 60 minus 30 equal to 30, 80 minus 20 is 60, 14 minus 32 is negative 18, and 44 minus 40 is 4. That's all for this episode. Goodbye for now. Stay safe.